In the North Atlantic and the great rivers that pour into it, there is a legendary fish whose future is now on the brink: the Atlantic salmon. It travels thousands of miles from river to sea, facing great risks and then returning back again.
There's something very special about the salmon. It's homing to its place of its birth.
Once salmon leave the streams of their birth, they live a phantom, unknown life at sea. Magically, they reappear some years later, called back to the very river where they were born. Whole communities once flourished on this bounty from the sea, but now something mysterious and deadly is happening to them.
We know that we send out a lot of smolts to sea each year, and they're just not coming back.
This is my way of life, it's my family's way of life, and it's part of the fabric of Scotland, and we want it to continue for many generations to come.
Somewhere on the salmon's epic journey, these remarkable fish are now dying in huge numbers.
There's a mystery of smolts and why they're not coming back, and it's very important to understand where this mortality is occurring.
In the last 30 years, returning populations of wild Atlantic salmon have dropped by 70%. To save these salmon, first we must find out what is happening to them. For some, the problem is clear.
Principally, the problem is that we have been killing too many fish for too long. Governments and scientists don't accept this, they don't recognize this.
Others believe there's more to understand.
The ocean's really a big unknown for salmon. We have these big picture ideas of what goes on, but we really don't know any of the details.
I just implore anyone that can influence what's going on at sea to do so. Pick up that ball and run with it.
With livelihoods at stake and a natural wonder in danger of vanishing, now scientific detectives race to solve the mystery. And for the first time ever, an international team heads out into the North Atlantic to find why the wild Atlantic salmon is lost at sea. Our relationship with salmon is ancient and powerful. The oldest known image of one is carved 25,000 years ago on the ceiling of a cave in France. The Romans, when they invaded northern Europe, marveled at its acrobatics and called it salar, from the Latin salire, the leaper. Standing stones carved with its image are one of the few remnants that an ancient people, the Picts, left behind over 1,000 years ago.
We're here at Glamis in the precincts of the Kirk, and here, next to me, is the great Glamis stone, which is world famous, largely because of this etched salmon, wild Atlantic salmon. Now, this was probably carved by a Pictish engraver about 12 to 1300 years ago. The Picts were here in Scotland in the 7th, 8th and 9th centuries, and their culture focused on the natural environment in a very special way. If you look above the salmon, you'll see what people, I think incorrectly, describe as a serpent. I don't think it's a serpent at all. I think it's an eel. And the thing about the eel and the salmon is that both migrate. They're fish that cross human boundaries. They're fish that pay no attention to political frontiers. They travel the oceans. The eels, as we know, go to the Sargasso Sea to spawn, and where their young are born, and then they come back. And the salmon come here, and they spawn, and then the small fish go to sea to get big. So this sense of the community-based culture, attributing to these remarkable animals an almost mystical sense of wisdom and understanding which they themselves were unable to grasp.
For millennia, around the North Atlantic, people awaited the annual return of the great fish. In Ireland and Scotland, the salmon fishery was a way of life. It fed whole communities. The ancient fishing village of Claddagh at the mouth of Galway Bay in the west of Ireland dates to pre-Christian times. And so valued were the fish to the town of Galway that a watchtower was built in the mid-1800s to announce the return of the salmon to the Corrib River. Salmon not only filled stomachs, it fed dreams. Taking this great fish on a gossamer line was soon a lifetime's thrill. Upper classes embraced a new sport, and great estates flourished. Here in the heart of Scotland, salmon angling was born. Fishing the wide Spey River required its own rules, a custom fly rod and a unique cast to reach pools where the great fish, fresh from the sea, had gathered.
My family has run and owned and organised fishing here for centuries, not just decades. And my children have caught their first fish on the river. I could show you the point where everyone caught their first salmon. It's an iconic moment.
20 years ago, as many as 3,000 salmon were taken on this stretch of river. Today, catches are now less than 1,000.
The fish are no longer there, and it's gone from harvesting a surplus to worrying about whether there are any fish at all. The local economy is massively influenced by what goes on in this river. And even in the best of days, it can be quite an elusive salmon, but at the moment it's particularly elusive.
Good luck, I'll see you in 4 years.
On both sides of the Atlantic, great salmon rivers are losing their fish. In the late 1800s, a daughter of Queen Victoria and her husband, the Governor-General of Canada, came to the Grand Cascapedia, bringing the sport of salmon angling across the Atlantic. The river teemed. Soon, dignitaries and tycoons were attracted to this beautiful, remote area, for some of the largest of the species came to this river. But that was over a century ago, and much has changed. On the great fishing rivers all around the Atlantic Rim, salmon are disappearing fast. In the last 2 decades, some new unknown disaster has emerged. Somewhere on the journey between young salmon heading out to sea and adults returning to spawn, their numbers are being decimated. For scientists, the race is on to find the cause. But if they fail, this magnificent creature may soon be gone.
We had a recent massive decline in the return rates of wild Atlantic salmon from the ocean to the rivers. And the key is to find out where and when the mortality is occurring that is causing the salmon to decline. Right now, I must admit, I'm totally flummoxed.
Over the course of all the different environments and over the course of the life cycle of a salmon, there's a lot of different threats that can be impacting its productivity. A wide range of things are happening in the freshwater side. In the ocean, salmon are dying in the ocean in relatively high rates, higher rates than we've seen prior, and we don't know why.
But today, researchers are tracking salmon at every stage of their remarkable life's journey. The many thousand-mile migration from river to sea and back again. It's a challenging journey of discovery. Salmon evolved in the ocean, and for millennia, this was their home. Their life in rivers began after the last ice age, when huge glaciers and sheets of ice covered much of the northern hemisphere. And when the earth warmed, the ice started to melt. As the glaciers retreated, they gouged out the earth, causing deep trenches that turned into rivers. One of the first fish to colonize these new cold rivers was the Arctic char, a close relative of the salmon. They still thrive in the Arctic today. But as the ice retreated, ancestral salmon pioneered new rivers all over the North Atlantic, safe havens to lay their eggs. Over time, they adapted to each river as a genetically distinct population. And today, no 2 rivers hold the exact same genetic strain of salmon. In a clear, protected stream, buried in the gravel, are salmon eggs. This is where life begins. It is now early spring and the eggs are hatching. Less than 1% of these eggs will survive to make their way to the sea. These newborns remain in their rocky nest for up to 12 weeks. Once they have consumed their surrounding egg sacs, they are ready for the next chapter of their lives, feeding voraciously on microscopic life. Within a few months, they are transformed, with distinct markings to help them blend in with the river. They dart up to the surface to catch a variety of insects. They will remain in the rivers for 1 to 6 years, preparing themselves for the next stage. They take their cue in part from water temperature. When warm enough, they set off downstream on the great journey to the sea. This is where the mystery starts. On the River Finn in Ireland, biologist Art Niven and his team monitored the juveniles. A low-level pulse of electricity temporarily stuns any fish, allowing the scientists to count them.
We conduct an annual program during the summer months of electrofishing to collect the juvenile fish, and we can look at their age class and their age structures, and we then release those fish alive back into the river. So it gives us a unique opportunity to have a snapshot to see the health of the juvenile populations within the river at that time. We also monitor the chemical water quality. We collect water samples in a bottle and take them back to our own laboratory for analysis.
Art and his colleagues have found the river is healthy, with an abundance of youngsters. An extraordinary transformation is happening in rivers and streams each spring. Juvenile salmon are growing into what is known as smolts. Their bodies are becoming streamlined for long-distance travel, and their coats are turning silver, camouflage for life at sea. Until recently, no one knew their fate from this point on. On the far side of the Atlantic in Canada, some young fish are about to encounter this ingenious device, a smolt wheel. As the wheel turns, passing fish are trapped inside. Biologist Jonathan Carr of the Atlantic Salmon Federation inserts an acoustic tag in a fish. As they pass receivers placed downstream, they emit a ping that identifies each individual fish by a number, thus allowing the biologists to determine how many are making it downriver, into the estuary and beyond.
These are the type of receivers we put out. So as a fish is swimming by with one of these tags, the receiver will pick up the signal and record right down to the second that this fish moved by and the tag ID to basically cover the width of the river so that we know exactly when the fish is moving by.
Jonathan has tagged 40 fish today. The next day, he heads downstream to the mouth of the Cascapedia to check the acoustic receivers.
It tells us on the side of the screen here, 39 out of 40 fish gone by this unit.
Oh,
pretty good information.
Yeah.
Most of them made it out. Some of these fish, after release, it only took a matter of 1 to 2 hours before they reached this point. And a release site was about 10 kilometers, so these guys are moving pretty fast.
So far, numbers are reassuringly high, indicating that the real dangers lie elsewhere. But on the nearby Miramichi River, young fish are under attack by a new predator. Once protected, the striped bass population has recently exploded. Huge numbers of these voracious predators spawn in the Miramichi Bay just as the young salmon are heading to sea. They don't stand a chance. Across the Atlantic, warming seas lure southern fish, such as the striped bass, to northern waters. Another challenge. Acoustic receivers tell us that only 3 out of 10 young fish survive the Miramichi and make it past the striped bass and into the Gulf of St. Lawrence. But on the Cascapedia, only 250 kilometers to the north, there are no spawning striped bass, and fully 8 out of 10 survive. Farther out, the next set of receivers tells us that only 50% of adult salmon that have already spawned and are returning to sea make it out of the Gulf of St. Lawrence. This is an ominous sign. Biologists know that 25% are being eaten by predators, but they don't know what is happening to the rest. Scientists haven't yet been able to verify how many of the young make it into the ocean. The survivors are now ready for the estuary, a zone where freshwater and saltwater mix. In this disorienting world, their bodies complete the final change for life in saltwater. But now they encounter yet another new threat. The Bay of Fundy, one of the most concentrated fish farm sites in the world. For a young salmon on its way to sea, these fish farms can be deadly. Food pellets sprayed into pens rain onto the sea floor and mix with fish waste. Caged fish are checked regularly for parasitic sea lice, which they can attract in large numbers. These parasites occur naturally in the wild but proliferate around fish farms. They can savage populations of sea trout and migrating wild salmon.
Wherever net pen salmon aquaculture is practiced, wherever there is large concentrations of these salmon farms, wild Atlantic salmon are in serious trouble. The industry grew and grew and grew, and all of the wild salmon rivers that flow into the Bay of Fundy, the wild runs declined to the point that now, where once there were 40,000 wild salmon coming back to those 30 great little rivers, big salmon included, now there's just a few hundred. Probably the most significant threat open net pen salmon aquaculture is when farm salmon escape, and they escape in the tens of thousands, sometimes hundreds of thousands, every single year. And the ones that survive, when they get the urge to spawn, they're running up wild salmon rivers and interbreeding with wild fish. And just after a couple of generations, you've got a hybrid, and the survival of those hybrids are very, very poor. I mean, the genetic changes are forever.
When Jonathan Carr isn't tagging fish, he is checking for escaped farm salmon. Scales show growth patterns which instantly identify a farmed salmon.
Hey, Graham, what's in that? Graham, does it look like a wild salmon or a farm salmon?
It's definitely an aquaculture salmon based on the scale.
Salmon aquaculture began in the 1960s with only a few commercial farms. But today, this industry is producing an estimated 530 million farmed fish annually, compared to a dwindling population of only 3 million wild salmon throughout the entire North Atlantic.
Solutions would be to regulate the industry more strictly, make sure that there is reporting, enforcement to make sure that we have the very best practices. The ultimate solution is closed containment, and whether closed containment on land or closed containment in the ocean so that the fish simply can't escape. It's a better operation for the industry as well as for the environment, wild salmon, because the farmer controls his environment. If there is disease, there's no disease spread. Everything is self-contained, no escapes.
On both sides of the Atlantic, the survivors now head into the open ocean. An ancient genetic code compels the salmon to migrate to the ocean, turning north towards their distant feeding grounds. They travel near the surface with other schooling fish, including herring and mackerel. But along the way, dangers abound. Attacks come from below and above. Easily spotted near the surface, they're vulnerable to diving birds, voracious bluefin tuna, and giants from the deep. But the presence of predators alone cannot account for millions of salmon disappearing each year. There is something fundamentally different in the ocean today. The Celtic explorer is setting out from the west coast of Ireland into the North Atlantic on the final journey of a 3-year research mission, SALSI. Salmon at Sea is the most ambitious program ever launched to study wild Atlantic salmon. The scientists must discover their age-old migration pathways up to the Arctic feeding grounds and find clues about what is happening to them along the way.
There are very few fish that roam as far and as wide as the Atlantic salmon. It ranges from the very edge of the ice fields right down to the orange groves of northern Portugal.
Finding these tiny salmon in the surface layers of the ocean is a daunting task, but the team has vital intelligence from which to work. Based on known currents and the expected migration speed of the fish.
We wanted to know how fast the fish went, and we wanted to know the direction they went in and what currents they used when they were moving north through the Atlantic. And these models have done an incredible job for us, because not alone have they told us the answers to those questions, but they have delineated, they have actually described for us and mapped for us individual corridors where very large numbers of salmon congregate.
Before SALSI, almost no one had studied wild salmon in the ocean before. Far out to sea, the Celtic explorer is on its mission to find the migration paths. They follow the continental shelf edge north, where there are strong currents and a gathering of sea life. Searching for these small fish in a vast ocean is something that has never been attempted before.
People have told us, where salmon smolt at sea, they've never seen them. Even though I spent 6 years in the Arctic, I've never seen salmon smolt, so hopefully this is going to be something exciting.
At regular intervals, they sample near-surface ocean temperature and salinity. The plankton net collects available food, vital for baby salmon to continue their journey.
The growth pattern of these fish can actually tell us how well these fish are doing.
The surface trawl is hauled in after hours of fishing.
The main thing is going to be the fish coming through the hopper. When they start coming in, that they're going to come in pretty fast and furious, so we need to sort them very quickly.
The first trawls are loaded with mackerel. Where are the smolts? Trawl after trawl brings in thousands of mackerel. At last, deep among the great mass of mackerel, they find a few young salmon. They are immediately transferred to the lab below. A clip from each fin provides vital DNA,
These are very precious fish. So really I think this is where the genetics comes into its own. Because they're so precious, we want to get as much information as we can from those fish. This technology, this technique, the genetics, will allow us to determine the river of origin.
The DNA samples will allow them to trace the migration routes of salmon from different rivers.
When salmon go to sea, they have a great ability to lay down in their scales the history of their journey at sea. And it's very much like the rings on a tree, but much more sophisticated, because not alone does it tell us where the fish went at sea in terms of the chemical composition at the scale, but it also tells us how fast they grew at sea.
Scale samples from each fish will be compared with samples taken decades earlier to see if marine growth has declined and why.
We can look at their life histories in the period from when they left the river to the period that they arrived at the feeding grounds. What was the quality of the environment? So I think these are the kind of little pieces of the jigsaw that we're starting to learn now that will be incredibly valuable as we go forward. But it allows us then to say something about the conditions that are in those locations. The plankton, the quality of the feeding. More importantly, the quality of the fish. Are the fish full? Are they starving? What's their condition?
After days of trawling and sampling, the team has found hundreds of juvenile salmon. Scientists can now begin to piece together the journey to their North Atlantic feeding grounds. Salmon from southern rivers leave first. They are joined by other populations, river by river, as they head north. They arrive at the first feeding grounds. Some salmon will return to their natal rivers after a year. Others will continue the journey to the feeding grounds off West Greenland. One of the Celtic explorers' key findings is that many of the fish they sampled were thin and undernourished. The cause was distressingly clear. In some areas, Celtic explorers' special plankton net came up completely empty. And the conclusion is simple and alarming.
There's probably large-scale climate forcing mechanisms that are occurring. There are well-documented changes occurring in the ocean and the environment. Temperatures are getting warmer, it's changing current flows, it's changing prey distribution.
The seas are changing. The Salmon project tells us that salmon must adapt if they are to survive. They have already survived 2 ice ages, but can they now adapt as fast as the changing world they inhabit? Salmon discovered an unexpected threat facing European salmon. Commercial fishing trawlers targeting mackerel were right in the migration path of the young salmon. The discovery that the trawlers were active in these migration corridors underscores the urgent need to create protected seasons during which trawling would be prohibited in these waters. Yet, facing brutal odds, some salmon do reach journey's end. Here, they encounter a very different world, Greenland. After a grueling journey, the salmon that have made it this far, at last, find a safe haven. These cold waters are incredibly fertile, and they feast on capelin, fish rich in oil and protein. The salmon will feed here for 2 to 4 years, sometimes growing to immense size. For thousands of years, this was where they thrived. But then, just 50 years ago, a small band of fishermen netting off West Greenland made a startling discovery when they came upon the salmon's secret feeding grounds. And word traveled fast, and soon fishing ships from all over Europe converged here. This remarkable footage, taken by angler and conservationist Lee Wolf, documents the tragic tale.
This is a 20-knot ship of 200 tons. In her hold, she has 36,000 salmon, taken in a little over a month of fishing. yard by yard, the 18 miles of continuous net comes aboard, and with it come the salmon.
In 1971, their catches peaked at nearly 800,000 salmon. And this set the salmon on a downward spiral. Scientists calculated that in 1972 alone, netters removed 1/3 of all salmon swimming off West Greenland. Fortunately, the crisis was recognized. The following year, an embargo was established on international boats. 10 years later, the North Atlantic Salmon Conservation Organization was formed as a formal international treaty organization to protect the Atlantic salmon. By the late 1980s, quotas were established, and a decade later, Greenlanders agreed not to export any salmon. It was a vital step in saving the species.
Described by some as a United Nations for the Atlantic salmon, NASCO has as members most North Atlantic governments with salmon interests, and additionally about 40 non-government organizations from countries all around the North Atlantic. One of the immediate benefits of the NASCO treaty was that it established an enormous protected zone free of fisheries for salmon in the North Atlantic.
Greenland is the principal feeding area. The fishery is a problem because it harvests salmon from all rivers. The fishery at Greenland was where all of Atlantic salmon from eastern Canada and the U.S. congregate for a couple of 3 years to feed, so that's the principal feeding area. It's a mixed stock fishery, so you have Atlantic salmon from a whole bunch of different rivers, both sides of the Atlantic, mingling the ocean, and there's no way for the Greenlanders, when they put a net in the ocean, to just focus their fishing pressure on a healthy population as opposed to pulling up the nets, and maybe they have a few salmon from the St. John River, which is threatened, or the Penobscot River in Maine, which is threatened. If they're going to have a fishery at any sustainable level, you've got to think about the future of the species. And I think they've realized over the last number of years they've seen fewer and fewer fish. Their quotas negotiated by NASCO have been reduced year after year after year. The scientific advice is there should be no fishery, so even a very small fishery is problematic for a lot of our salmon runs here in eastern Canada.
The Greenland quotas were a sensitive issue for local fishermen. Conservationist Ori Vigfusson, in partnership with the Atlantic Salmon Federation, began working with local fishermen in order to reduce catches of salmon.
22 years ago, I set up the North Atlantic Salmon Fund for the sole purpose of conserving salmon the fastest and the most effective way, i.e. using commerce to do it. Actually, to pay fishermen not to fish. I buy back their fishing rights. I have raised millions and millions of dollars this way, mostly from the private sector. We have been very successful in brokering commercial agreements with the fishermen who have voluntarily agreed not to harvest the salmon in return for development of other employment, other fisheries that are sustainable.
Some small-scale fishing does still happen here. Greenlander Johannes Heilmann is a traditional fisherman. Today he will stay close to his island shores and will fish for salmon. His catch will only be sold in local markets. Close by, other fishermen net cod, a fish that has recently rebounded. These men are the face of Greenland fishing today. The Salt Sea program has helped us to understand the migration paths to Greenland, but we still know very little about the return journey. Marine biologist Tim Sheehan and his colleague Rasmus Nygaard are trying the near impossible: to hook a large salmon in the ocean, reel it in safely, and fit it with a satellite transmitter, then set it free. This is the first attempt to track the salmon migration from Greenland waters.
No scales.
The ocean's really a big unknown for salmon. We know these kind of general trends, where they go. They're feeding off of the coast of Greenland. They're feeding in the Norwegian Sea. We have these kind of big picture ideas of what goes on, but we really don't know any of the details. These different research activities that we're undertaking are really trying to fill in a lot of those pieces and give us a much better idea as to what's going on, not only in freshwater, but also in the ocean during the salmon's life cycle. These tags will give us a better idea as to the routes that they're taking to migrate home. And by tagging them at Greenland before they go home, we can look at that second half of the migration.
The pop-off tag has been designed to stay attached to the fish for 8 months. After that time, the tag is released and floats to the surface. And the information it carries is downloaded from a passing satellite. Now, for the first time, Tim is able to trace the beginning of the salmon's journey back from Greenland. It is an important step in this new tracking. Remarkably, the fish dove far deeper than anyone predicted, some 700 meters into the dark abyss.
This is the first time that this has been done. First look into the environmental conditions that salmon are experiencing as they're off the coast of Greenland and as they begin their migration home. We can start looking at some of the oceanographic conditions in those areas at that time, what has changed, start forming hypotheses as to what could be driving the mortality that we're seeing in the ocean.
The truth is, we still know very little about the salmon's journey home. But we do know that the number of salmon returning to their rivers after their great North Atlantic migration has dropped by 70% in the last 3 decades. It is now springtime. The great salmon that have spent years at sea now return to the rivers of their birth, guided in part by the distinctive scent of its waters. Now full grown, instinct drives them to fresh water to spawn. But this journey too is far from easy. In Scotland, a resident pod of dolphins awaits their annual windfall. Strong currents in the Moray Firth virtually deliver the salmon straight to them. Some are taken, but many escape. All around the North Atlantic coastlines, the great salmon runs have begun. A small commercial fishery operates in Montrose Bay, Scotland, a 4th-generation family business. George Puller is part of a deeply rooted Scottish tradition.
Our family business was established in the late 1960s by my father and grandfather. At one time, there used to be netting stations throughout Scotland, almost on every part of the coastline. But what has happened was, in the late 80s, the fish farms reduced the price of the wild salmon so much because the customers didn't really recognise the difference between a wild salmon and a farm salmon. Since then, the wild salmon has rallied in price, but the netting effort now is only about 5% of what it was in 1952. So there's only a handful of people left in Scotland that do this kind of work.
For centuries, these small-scale fisheries were sustainable. Now, along with the declining runs, their numbers have plummeted. George and his family face a challenging future.
Our fishery here, it was started in the early 1800s, and it's it's part of the fabric of Scotland, and we want it to continue for many generations to come.
The Scottish government felt the threat to the salmon was so severe, it recently placed a 3-year moratorium on any taking of wild salmon in coastal waters. small fisheries are not the only communities to suffer as salmon stocks decline. Upriver, the fabled sport of salmon angling is changing too. Angling for salmon is not only the fabric of Scotland, it is the heart of life on the rivers of Ireland, Norway, Iceland, eastern Canada. This is no overnight sport, but learned with lessons accumulated over a lifetime. Atlantic salmon are already extinct in more than 300 rivers. Far upriver, the journey is almost over. Researchers are tracking how many have survived. The waters of the Miramichi River in Canada were famous for enormous runs of Atlantic salmon. Just a few decades ago, 25% of all salmon bound for North America came to this one river alone. 100 kilometers upriver, Mark Hambrook and fellow biologists are netting a protected pool in autumn to count the returning fish. The salmon have lost their silvery sheen and changed into their striking spawning colors, the russets and browns of autumn. Among the few that return, they are finding a wide variety of ages. Some left for only 1 year, others stayed away for up to 4 years. By spreading the risk over many ages, nature ensures the species is never brought down by one generation. However, every year, fewer and fewer return. These are the fortunate ones. The concern is about those many others lost at sea. Where once 500,000 adult salmon came here to spawn each year, now they number less than 40,000. This is a monumental decline.
Wild male salmon.
So many set out, so few return. But we now know more about the salmon's incredible journey than ever before. As the investigators compile the data and share their discoveries, a complex and alarming picture emerges. Young fish are leaving the rivers earlier than ever before, triggered by warming waters. Salmon are cold water fish.
As the smolts grow, and as they grow faster, they reach the smolt stage, the stage when they can go to sea. They reach that earlier, sometimes a year earlier than they did previously. The fish are then small fish, but still ready to go to sea. But those small fish, once they go to sea, are much less fit. And really, the survival rate of these smaller fish when they go to sea is a lot poorer than the bigger, older fish that we had in the past.
They are challenged even before they make it to sea. Once at sea, the young salmon are unable to find the food they need to grow and survive. The plankton and larval fishes have moved north due to the warming waters. And salmon from southern rivers have to travel farther and are weakened by the lack of food and are more susceptible to predators. Even adult salmon are finding it hard to find their preferred food in a changing ocean. And when they return, many are not in optimum condition for spawning. These findings are all linked. The Atlantic Ocean is changing fast, and maybe faster than salmon can adapt. The salmon are getting lost in the wrong place at the wrong time, failing to find food or encountering enemies they never knew. warming water lies at the heart of the mystery.
What we now know is that climate change has impacted directly and very severely on Atlantic salmon at sea. Really, the way it has done this is through the temperature changes that have happened in the surface of the oceans. As a result of these temperature changes, we find that the plankton is actually moving north. Species of plankton that are comfortable in water that is reasonably cool now find conditions to be entirely unsuitable. And each year they're moving further and further and further north. What we do know is that conditions are changing. And always when you get a big change in an ocean, you're going to see an increase in terms of mortality as the fish changes and as the fish adapts. 20, 30 years ago, there would have been in the region of 7 or 8 million Atlantic salmon at sea. That's now down to about 3 million, and as far as we can see, is continuing to drop.
Changing ocean conditions will require international cooperation to protect the salmon. We must also turn to freshwater to make sure we have clean rivers and estuaries, unobstructed passage, good spawning beds, and healthy nurseries for the young, to send as many salmon out to sea as possible. As the salmon are adapting and changing to the new ocean conditions, we must reduce man-made pressure to give them time to adapt. One solution is to create protected migration corridors from the remotest spawning beds, all the way up to the Arctic feeding grounds. But there are some stories of hope. People who are fighting for the species and making a difference. The Penobscot River in Maine was once a great salmon river, until dams blocked the way for migrating fish.
I'm looking at a broken river that we've had here. You know, for over 100 years, we've had this dam and then several other dams above it. You know, we've tried to build hatcheries to put fish in above these dams, but we've never really addressed the problem that there are just too many dams in this river. And the VZ Dam here, this dam is at the head of tide. 100% of the spawning grounds for species like Atlantic salmon are all above this dam. These dams on the main stem river were built back in the 1930s. So since that time, salmon have come to these dams and not been able to then get any farther their spawning grounds. Over time, we've built fish ladders that largely haven't worked. We've had 2 studies in the last decade that have said if we're going to restore Atlantic salmon on these big rivers in Maine, like the Penobscot, we have to reduce the number of dams. And the Penobscot project does that. This project will remove 2 big main stem dams and bypass a 3rd dam. So we're addressing the root of the problem for the first time on this river in 183 years.
But in recent years, heroic measures were taken to rescue salmon. Lift them over the dam and release them upstream. These are some of the last remaining Atlantic salmon in the United States. But today, this river is about to be restored. The Penobscot River Restoration Trust was formed to buy 3 dams on the river, remove 2 of them, and build a fish pass around the 3rd. The first to go was the Great Works Dam, and then the VZ Dam was breached. It opened up more than 1,000 miles of spawning habitat.
So today, we celebrate the taking down of this great dam behind us. So you'll be seeing a whole new river here within 1 year. But when you see projects like this taking place on the Penobscot River, it inspires people to do even more.
And when a dam was removed on the nearby Kennebec River in Maine, fisheries biologist Nate Gray witnessed just how soon life returned.
Because of the work that we've done here, it's revitalized this river. The river is a living, breathing creature. The alewives, the river herring here, are the prime driver of the marine and freshwater ecosystem interface. The river herring are the base of that food chain. The salmon smolt outmigration almost perfectly coincides and overlaps with the influx of this huge biomass of river herring going upriver. So you have the smolts dropping out, trying to get out to the ocean, and then you have the river herring pouring in at the same time. And any predators like cod or haddock or halibut that are hanging out at the river mouth are much less likely to eat a salmon smolt because there's so many river herrings. And the restoration of these keystone species could very well be the tipping point for salmon coming back to this river.
In Iceland, there's another story where humans are making a difference. This ancient landscape, little touched by time, is a haven for salmon. But there are rivers with obstacles too high for them to overcome. One man decided to help nature along.
Yeah, we are now on the river Tungufljót. It never had any salmon in the past because you can see this big waterfall here. It's a huge waterfall. And the salmon were never able to run the falls. They were simply just too high for the fish. So what I did, I leased the river for a long period of time, and I decided to make a fish ladder into the waterfall to enable the fish to go through the falls up to the spawning ground. So we built the salmon ladder, but of course there were no salmon to run the ladder because they have never been here. So I got some salmon stock from the neighbor rivers. So we released this 10,000 smolts, and a year later we got 60 salmon back, which I thought was quite unique. That was the first salmon ever running this river. And we took all the 60 fish and we brought them up to the fish hatchery, and we nursed the eggs, and we got another 60,000 smolts from these fish. And we released 60,000 smolts, and then we landed 2,800 salmon on this river, Tungufljót. So all of a sudden we have a new salmon river in Iceland. It's quite unique what is possible to do with nature if you help a little bit.
And so the great journey ends where it began. It has extended over thousands of miles and encountered every conceivable risk. What has made it possible was a heroic will, the primal need to reproduce and pass on its genetic inheritance. But the question remains. Will one of the oldest journeys soon come to an end? Or will the Atlantic salmon endure to inspire generations still to come?